Welcome to online lectures by CA Studies. For more lectures online, please do visit castudies.lk.
Alright, now let's look at complementary outcomes in probability. Complementary outcomes means you will see what will be the probability when comparing both situations. That means these two situations in this case. The event that will happen in comparison to the event it will not happen. This comparing thing is called complementary. Let's take the example of COVID. We said what will be the probability COVID would continue to the next 5 years. And there's a chance that it will continue and there's a chance it will not continue. Well, if the COVID's chance, will continue, what will be the chance percentage? We saw that it was 50% or in proportion terms 0.5. But the chance it will not continue, there is a formula that we can use rather than using our mind to simply calculate 0.5. And that formula is this: P A bar equals 1 minus P probability of A, where A bar is not A. That means A bar stands for this letter A with a sign of a slash above it stands for not A. So you got to memorize this formula. So what this formula suggests is trying to save your time. So you know there are maximum only two outcomes. Okay. Two maximum possible outcomes. This is only for scenarios where there are two outcomes only. Okay. Not three or more, two. So if there are two outcomes, the first outcome if it is 0.5, then we know the maximum number of outcomes is 1, isn't it? Because I told you here, I proved to you how it becomes 1. It becomes 1 when we add both probabilities. Therefore, if you minus 0.5 from 1, that is the probability that COVID will continue, then the answer won't it reflect the probability that COVID will not continue? It will reflect that probability because 1 minus 0.5 basically 1 minus 0.5 is equal to how much? 0.5, which is 50%, and it is right when we see this diagram. Both are 50%. So the same thing we got by applying this particular formula. Okay. So if they ask the complementary outcome or the other one straight away, now they might given the exam, the probability of COVID happening is 30%. Then what's the probability of COVID not happening? Simply if they give, what you should do? You should take 1 minus 30% or 0.3. That's how much? 0.7. So the probability of COVID not continuing will be 0.7 in that case. Okay. With that, we finish complementary outcomes, and now we are going to see an extension of links with complementary outcomes. So, you know that there are events. Okay. Those events can be of two types: dependent and independent. Dependent and independent. Another word for independent is mutually exclusive. Under dependent law or dependent events, we can apply two probability rules. That is the OR rule and the AND rule. Same way for mutually exclusive events, we can apply two rules. The OR rule and the AND rule. Okay. So, what is this OR rule we see here? Let's first of all look at OR rule with independent event. This is the O law for independent events. Here there is a new formula to learn. And that formula must be applied only when they give in the exam with the word O. They might ask, what is the probability of COVID continuing or COVID not continuing? Now the key word here is the word O. If you see in your exam question the word O between both events, then you must understand that this is relating to O law. Now, if it's the case, then firstly what you should do is, now first of all let me explain what are independent events. If you take event A and event B, independent means they are separate. They are not together like this, never. It is separate. That is called independent event. If you are to take the probability of COVID continuing or COVID not continuing, then simply apply this formula. And in this formula you see this sign here. That is the sign for O law. So sometimes in the exam they will give this sign straight away. Then you should understand if they give this sign, it means they are reflecting the word O. And O involves adding both probabilities. So probability that COVID continues is 0.5 we found. And probability COVID not continuing is again 0.5. Then let's now find the probability of COVID continuing or not continuing. Okay, which will be equal to probability of COVID continuing plus probability of COVID not continuing. Then what will be the answer? The probability of COVID continuing we know is 0.5. Put 0.5 here. Plus the probability of COVID not continuing is, we know again it's 0.5. So enter the answer. Then what will be the answer finally? 1. See? So the answer is 1. If they ask when COVID continues or not continues, what will be the probability? First of all, you decide, okay, they gave the word O. If they gave the word O, then I must add the both probabilities, but I will also add them only if the both possibilities are independent. It is very important. Now independent events means that both events don't affect each other. That means if by COVID happening will not affect COVID not happening, and COVID not happening will not affect COVID happening. That means it's a bit weird, right? But it's like the demand for books and the price of sugar. Demand for books and price of sugar don't have any link at all. That's how we define an independent event. Okay? If you come across independent event and the word O, those are the two criteria. You can make a note. Criteria for this is, in the exam question you must check whether it's independent event and whether it is having the word or. If it does have the word or, then you should apply the above formula. Next, let's look at or for dependent events. Next, let's look at and rule for independent events. Now, when it comes to the and law, here the criteria is you should check whether it's an independent event. Okay? And also you should check whether the examiner has given the word and. If they asked what is the probability of COVID continuing and COVID not continuing, then your answer should be probability of COVID continuing represented by the letter A multiplied by the probability of COVID not continuing represented by the letter B. Then your answer would be something. It can be anything. Okay. But there is a situation when these two multiplication result equals to 0. When it equals to 0, they say that the event A and B have mutually exclusive outcomes. That means the results of A and B are also independent. They are not dependent. Let's say COVID continuing and there is a recession in the economy, downfall in the economy. Whereas COVID not continuing will create a boom in the economy or a rise in the economy, right? So the recession result and the boom result doesn't have a link, isn't it? They are independent. That is what is meant by the outcomes being mutually exclusive. So how you will get the answer 0 when you multiply two probabilities? That is when one of the probability is equal to 0. Either A can be equal to 0 or B can be equal to 0. One of the two, if it's 0, then your ultimate answer will be 0. And if your ultimate answer is 0, then the event A and B have mutually exclusive outcomes. Okay. So the criteria here is that you must check if it's independent and you must check if it has the word and. If the examiner asks the probability of both events with the word and. Alright. And the AND rules have the symbol, see, the reverse of U. So if you see the reverse symbol of U, that means it represents the word AND. Right. So with that, we finish the AND rule for independent events. Okay. Now let's look at dependent events and the particular O rule. Now, in dependent events, your diagram will basically look like this. Okay, so let's see the O law applicability for dependent events. Now, the first, so if you are to analyze this particular diagram, if you are to analyze this particular formula, you see that you have to basically add the both probabilities and minus it from the AND rule probabilities. Now these AND rule probabilities, there are two types, isn't it? We have dependent AND rule and independent AND rule. For this formula, you must use the independent AND rule. Okay, where you multiply both probabilities as we saw here. Okay, so here you should use the independent AND rule. Now, let's see how to do a particular question in line with an example in your textbook. Let's look at this. If one card is drawn from a normal pack of 52 playing cards, what is the probability of getting an ace or a spade? I told you all previously the exam question will have the word O and you see this is how they will ask this question. Asking the probability of getting an ace or a spade. You see the word or. So now I will teach you some steps to follow when you answer probability questions. The first step you need to follow is identifying whether the events are independent or dependent. Next, see what the examiner mentioned, whether the word or and. And thirdly, identify the law you need to follow. And fourthly, fill up the formula. So first thing, identifying whether the events are dependent or independent. Now they are asking, the events that they are asking about is only whether we can get an ace or a spade. Okay. So ace and spade. Now, is ace and spade depending on each other or is it separate, two separate things? If you take a card pack, you have spade, club, diamond and heart. And how many cards for spade? You will have 13 cards. Club 13, diamond 13, heart 13. Totally how many cards? 52 cards. That 52 only they have said here. Right. So where will ace be? Ace are a part of these 13 cards, isn't it? So we will have one ace of spade, one of club, one of diamond and one of heart, which will make 4 aces in the card pack. Now, our ace is within these 13 cards, isn't it? It is not a separate card. If you have played card games, you will know that ace is not a separate card like spade, club, diamond. It is inside spade, it is inside club, inside diamond, inside heart. So what does this mean? It means that ace is linked to spade or club or diamond or heart. So since we are asked about spade and ace only, we can conclude that ace and spade are dependent events. Okay, that means something like this. You have ace represented by the letter A and spade represented by the letter S. These are not independent, they are dependent. And they are asking what is the probability of getting both a spade or an ace. Now, second question we come. See what the examiner mentioned, whether the word or and. Well, the question clearly states the probability of getting an ace or a spade. Since the word O is there, we conclude at that point only we have to actually check whether word is O and with the word between both events. Okay? So it's O here. So you put O. Now identify the law that you need to follow. So you surely need to follow the O rule. But which O rule? Dependent events O rule or independent events O rule? Which one you should follow? You should follow the dependent events O rule. Why is that? Because both events are dependent and we got the O rule here, O word here. So it's O rule dependent. Now what is the formula for O rule dependent? We just saw adding probability of A plus probability of B minus the probability of A and B, but this AND rule is applicable for independent events. Okay? Independent event. Okay, so this is for independent event, don't forget. Okay, if not you will confuse. Alright. So this I meant this P and A only, not the entire formula. The P and A part only, this part only is independent. Right. So how you fill the formula? Now we know the formula is P probability of A's plus probability of spade minus probability of A's and spade. What is the probability of having an ace? Now we have to apply a probability formula, which is this. Probability equals number of ways of achieving the desired result divided by the total number of possible outcomes. What is the total number of ace cards available in a card pack? 4, isn't it? Because we saw that from each set we got one ace, totaling to 4 aces. So basically there will be 4 ace cards. Then what are the ways of achieving ace? Well, okay, so now what is the probability of achieving an ace? Now, what is the total number of cards we can pick from the card pack? We can get 52 cards from the card pack because total available cards are 52. Inside this 52 only, these 4 A's is there. That's why I am not adding 52 and 4 because they are not separate cards as they are cards within this 13 card pack. Then, how many aces can I obtain from 52 cards? Only 4 aces because one from each pack category will be equal to 4. So my probability of having an ace is 4 divided by 52. Okay, you don't have to take the decimal, you can leave it as it is. Alright. Then you find the probability of having a spade. Now spade also the same way. What is the maximum number of cards you can get from a card pack? Where spade is, you can get 52 cards. But how many spades are available? Only 13 spades. Therefore, the probability is 13 divided by 52. Now, what is the probability of A and S? Probability of Ace and a spade. Now, here we have to apply the independent rule. Okay, make a note. Independent rule where what it says, probability of Ace multiply by probability of spade. That's the formula. So probability of ace is 4 divided by 52. Whereas if you multiply it by spades probability of 13 divided by 52, you will get the answer 4 multiplied by 13 divided by 52 is divided by 52 multiplied by 52. So if you basically simplify, it's basically 1 over 52. Okay, if you simplify it, because 13 into 4 is 52. So 52 divided by 52 multiplied by 52. So you can cancel the 52 above with one of the 52 in the denominator. Then you will be left with 1 over 52. Now that is the probability of having an ace and a spade. Now apply the formula. Probability of ace plus probability of spade minus probability of ace and spade. What's the answer? 4 divided by 52 plus 13 by 52 minus 1 over 52. Since the denominators all are in 52, we can straight away add and subtract the numerators, which will give us 4 plus 13 is 17 minus 1, 16 over, what is the denominator? Denominator is 52. It will remain as it is because all the denominators must be the same. I hope you all are aware of adding or subtracting or multiplying fractions. Then if you simplify this 16 by 52, you will get the answer 4 divided by 13. If you simplify, because 16 multiplied by 4 is equal to 52. So if you 16 by 1 and 16 by 4. So 4 divided by 13 will be the simplified fraction. Ultimately, what's the probability of getting an ace or a spade? 4 over 13. This is the probability of, you should say, therefore probability of getting an ace or spade or rule for a dependent event is equal to 4 divided by 13. Fine. You might be given the fraction or you might be given the decimal. Then divide and get the decimal. 0.307. Alright. So your answer is exactly 4 over 30. Okay. Now let's look at AND rule for dependent events. So far we covered O rule for independent events, O rule for dependent events, and the AND rule for independent events. So we are left with AND rule for dependent events. Now these dependent events are not mutually exclusive. So as usual, dependent events are usually as this, same as for or how we described. Event doesn't change no matter the rule, no matter the law. Events type is the same. It is both depending on each other. But the formula used is different. So for this we call this AND law for dependent events, we call another word conditional probability. That is the other word for it. Now conditional probability has a formula which is, if you take two events, probability of A and B, it will be like this, where you will have to multiply the probability of A with the probability of B given A, given that A. I'll tell you all what is this given that sign. This slash sign is known as given that. And if you take probability of A and B, you can also write the probability of B multiplied by the probability of A given that B. Now, let's use the example to understand this. So, let's look at this. Board of Directors of S Limited has warned that there is a 60% probability that a factory will be closed down. The factory manager has estimated that the probability of success in getting a productivity deal with the workforce is only 30%. Okay, let me show you this. Now there's a factory. You have less productivity, and the other option is you have more productivity. Your staff is productive your staff is not productive. Then if for your staff to be productive is only 30% chance. So staff not being productive, what's the chance? 70%. If your staff is not productive, they will shut down the company. They will close the factory. And closing the factory, they will have, so that is only 60% chance to close the factory. But when the productivity is not there still, they can open the factory also, because only 60% chance is available to close the factory. Then balance 40% chance is for what? For the factory to keep running. Okay, so there's a 60% chance that the factory will close, but since it's not 100% chance, there will be a 40% chance that the factory will keep running. Okay, so if the staff is productive, then they have not told what will happen anyway. Okay, now they are asking what is the likelihood that the factory will be closed. Okay, so if the factory, then what is the probability that factory will be closed? They are asking. That means this route, isn't it? So let's say now they are linking staffs, they are making the decision of closing the factory upon whether the staff will be productive or not. So the two events, identify the events, independent or dependent. Are they independent or dependent? They are dependent. Why? If the staff productivity is high, they will not shut down the factory. And if the staff's productivity is low, then there's a 60% chance to shut down the factory. So, staff productivity and factory closure are dependent events. Okay. If they are dependent events, we should follow either what law? Well, under dependent events, we have two types of laws, O and N. We decide which rule to use based on the word examiner gave. Now in this, they haven't mentioned any word as such. So it's interesting. What they have simply said is likelihood that the factory will be closed. Now, factory will only close if the productivity is less. So that means this is basically an and situation, isn't it? Because if the staff is not productive only, factory will close. So it is and, staff not productive and factory closes. It will not be staff not productive or factory close. It doesn't sound like that because they are more closely associated, isn't it? Okay. So let's apply this formula. Let's say staff's productivity is denoted by P and factory closure is denoted by C. Factory close and the staff's productivity. So the probability of P and C is equal to the probability of P multiplied by the probability of C. Okay. So the probability of P is what? 70%, because they told that staff being productive is only 30%. Now, this is where we have to go to learning a complementary outcomes, where what is the probability that the other thing will not happen. So, probability of P, which is staff not being productive, is equal to 1 minus probability of staff being productive. Always, because we know we are going through this complementary outcome formula, complementary outcome formula, because they have given the probability of the positive or probability of one event, isn't it? The event that we don't want, that is the productivity of the staff. Because they have said the factory manager has estimated that the probability of success in agreeing a productivity deal with the workforce is only 30%. So, if they agree with the staff to be productive or increase productivity, that agreement will become successful only with a 30% chance. So if it is successful with a 30% chance, then what is the probability that it will not be successful? That is a chance of 1 minus 30%, which is equal to how much? 70% or 0.7, which is here. Now the probability of C, that is the probability that the factory closes. They have given straight away in the question that the probability of the factory closing is 60%. As they say, 60% probability is there that a factory will be closed down. Okay, so 60% will be here. Now apply your formula. You should multiply the probability of P, where staff is not productive, with the probability of C, where factory is closing. Probability of C is 70% multiplied by the probability of factory closing 60%. Seventy percent multiplied by 60%. What will be the answer? 0.7 multiplied by 0.6 is 0.42, which is 42% or 0.42. Okay, so there's a 42% chance that the chance that the staff will not be productive and the factory will close. Alright, this is how you work out a dependent and rule variable. Dependent and rule probability, where you choose whether the factory closing is depending on the productivity. Now if you apply this formula here, now let's assume it is PA, it's P and C equal PP multiplied by P of C given given P in this case. So P is our productivity, and what is the chance our factory will close given that, which is denoted by the sign slash, given that our productivity is low. Okay, can you all understand the link between this given that? So if the probability of closing the factory, they are asking the PCP means the probability of closing the factory given that the productivity is low. So the probability of having a low productivity is 70%. Therefore, 70% multiplied by the probability of having the factory closed if the staff is not productive. That if word is only represented by this slash. Okay, if the staff is not productive is 60%. And so you get your work out the formula and you will get this 42% answer. Okay. So with that we finish the probability rules. Next let's look at something called contingency tables. In contingency table we will show all possible outcomes of an event in a table format. Okay, and these can be used to calculate conditional probabilities. That means the one that we just discussed. Or another word for it is AND law for dependent events. It can be used. This table can be used for finding conditional probabilities. Let's look at an example. Okay. There are independent probabilities. Okay, so that means independent. Okay, that means independent events, right, of 3 sections of management accounting department. Where, so they say the independent probabilities that the 3 sections of a management accounting department will encounter one computer error for a week are 0.1, 0.2 and 0.3. So there are 3 possibilities that we can have one computer error and they are 0.1, 2 and 3. And we will never have more than one computer error in a week. Now, they are asking, calculate the probability that there will be the following number of errors encountered by the management accounting department next week. Okay. Having at least one computer error. Okay. The probability of having at least one computer error is 1 minus the probability of not having an error. Now, you all have to follow a memorized approach here. Otherwise, it's for a new person, it's a bit difficult to catch on with the logic. So better follow a memorizing approach to first of all get the hang of it, and then later as you go you will understand what we do. Okay, but I will explain what the logic is. Okay, right. So now let's look at the data given. Independent probabilities. That means they have 3 guesses. Okay, that means for one outcome. Now let's say now they are saying that we have computer error. Now in computer error we can have one computer error for 1 week and no computer errors for 1 week. Now this is all for 1 week scenario. Okay, computer error for 1 week. So we can have one error. And we can have no errors. Here they are saying there is no, now about no errors they have mentioned, if you see this line, they say there is never more than one computer error encountered by any one section in a week. So, no errors at all. So, there's a 100% chance that there will be one error only, not more than one error. Sorry, here this is more than one error. So, this is actually more than one error. So there's no chance for more than one error at all because they say there's never, but they say at least one error can happen. Okay. Now that one error can happen from three departments. What are the three departments? We don't know, but some three sections in the management accounting system. Let's say, for example, bill section, invoice section, and order section in the management accounting process or department. Now, computer error, let's take, they are using Sage system. And in the Sage system, having an error in the bill section or invoice section or order section is possible with what are the probabilities? 0.1, 0.2 and 0.3. Okay. Now, we should see how to get the probability of having one error. Basically, now you can say whether the probability of having one error compared to having more than one error is 100%, of course. But we don't know this for sure because the question asks what is the probability of having at least one computer error in a week. So this is what we actually got to find. But of course we can't have more than one error at all. If we can't have more than one error, then the other possibility or other chance of having a computer error for 1 week is not having an error at all. If the probability of having an error is this much, then what is the probability of not having an error? There can be three situations for each bill, invoice and order. So bill, the probability of not having an error is 1 minus 0.1. What does this bring us to? The complementary outcome formula, where we say 1 minus the probability of having an error in a bill. So having an error in a bill section is 0.1, and if you minus 1 from 0.1, you will get the balance for which you will not have any error. Okay. So that's why they have set only two possible outcomes. To set two possible outcomes only, they have said that there will never be more than one computer error. Okay. And invoice is 1 minus 0.2, which is 0.8, and order section is 1 minus 0.3, which is 0.7. Now, the probability of having at least one error, you are going to learn a new thing. If you see the word at least, okay, then remember students, if it is at least, you must follow the complementary outcome formula, where you should get the difference from 1 minus the probability of not having, of the opposite of the event that we are looking for. Now the event that we are looking for is at least one error. Then what is the opposite of it? Not having errors. Not having errors, isn't it? So always at least rule, you make a note of it, at least rule. If you see the examiner asks something like what is the probability of having at least one something, then at least rule says you should use this formula. So the probability of not having errors is what? Well, the probability of not having errors, we should see whether the possibilities are dependent or independent. Here, independent probabilities, it doesn't mean that the event is independent. Okay, it's a bit fishy here. What they are saying is, even though the probability is independent, the connection between each other is there. Meaning, it is like the probability of something given that, like this factory and staff productivity. The probability of the factory being closed given that staff is not productive. Kind of linked. But here also they have found these probabilities that we will have one error by comparing each other. Okay. That is how we conclude that we should follow the AND rule here. Now the AND rule says we have to multiply all the probabilities. So not having an error. Okay, so not having an error means this section. In this section we have 0.7 probability of a bill not having an error multiplied by probability of an invoice not having an error multiplied by probability of order not having an error. Then what will be your answer? It will be 0.7 multiplied by 0.8 multiplied by 0.9. Your answer is 0.7, 0.8 into 0.9. Okay. Now apply to this formula, which is 1 minus 0.504. What is it? 0.496 is the probability of having at least one error. So what we newly learned is that we learned the at least rule, where whenever you see the word at least in the exam question, remember this formula. This complementary outcomes, complementary probability formula, which we learned previously. Okay, find the two events and find if at least one error means what is the opposite of not having errors at all. Now the opposite of at least one error is having more than one error, can be, or not having errors. Always you must choose not having errors. That means the no part, not at all part. Okay, where you will have not at all. That part only you have to choose when deciding whether it is a probability of at least something. Okay. Next, that is where you use the conditional table or contingency table. Probability that you will have only one and only one computer error. That means one and only one. If now let's go to the one and only one rule. In this one and only one rule, you follow the table format, contingency table format, where you draw up a table like this. Now there are three sections now. Section 1, Section 2 and Section 3, which we called them in our case the bill section, invoice section and order section. Since there are three sections here, I'm going to set 3 errors. Maximum, if we are getting one error from each section, we can have a maximum of 3 errors only, no? Isn't it? Because they are also asking for one and only error. So one error from each section, maybe. Maximum one error. So that's why I put 3 error rows here. Because they are asking one possibility of one error only. Now, if we are having one error in this row, it can be only from the bill section. and not from the invoice section or order section. If we are having an error in the second row, we may have no error in bill section but in the invoice section and not in the order section. In the third row, we might not have error in the bill or invoice section but have an error in the order section. Now, so we have at least one error in each situation. Now, what is the probability of this situation? That is what we need to find. Okay. So the probability of having an error in the bill section is 0.1. Okay. So you write 0.1 here. Let me. Okay. Invoice section, what is the probability of not having an error? That is 0.8. What is the probability of not having an error in an order section? 0.7. Okay. Now how you will get the total probability? Will you add or multiply? You will multiply. Why do you multiply? Because they are kind of linked and they are what do you call? They are supposed to be the AND law. We should follow the AND rule. That's why we will have to multiply. So AND rule is basically, it is kind of interlinked events only. But they are independent events. But we can talk about it like an interlink. Example for AND rule is having an easy paper with 15 questions. Okay. So or you might get a difficult paper with 15 questions. So this with word is coming in this situation. We feel the word with. If you feel such words, that means it should follow the AND rule. Right? So here it can be a bill error or an invoice error, but I wouldn't say or, because here we are looking for one and only error, so absolutely we should say as O, but in grammatically, but practically we can have error is interlinked with one of the section. It can be an error and the bill section. It can be an error and the invoice. You see, the AND word comes there only. One error and in one section. That because of this only we are applying the AND rule here, and the AND rule here as well. There we multiply all of this because there it is represented, the error comes from either bill or invoice or order. So these three are actually independent. These three are independent. True. Independent probabilities. That is correct. What the exam question has said. But it is linked to error. One error. So it's one error and bill. One error and invoice. One error and order. Because of that only we go for the AND rule. Remember, if you are drawing a tree diagram like this, if you multiply horizontally, if you want to get the horizontal figure, like of figure of one error, then you have to multiply this horizontal. But if you have to find vertically, you must add. That's the rule. Because it's bill or invoice or order. But when we talk with error, it is bill and error. Bill and error. Invoice and error. Order and error. Okay. So that's the reason for it. Now let's fill up these. So this should be 0.9. So this 0.2 and this is again 0.7. It will be, and then no, 0.9 here, 0.8 here, but for the order it is 0.3, which will give multiplication of all following the AND rule, because error and section gives us the AND rule. Now, but the possibility of having this when compared to other is or. You can have this, or you can have this, or you can have this. So in the O rule, what do? We add all the probabilities. Probability of having one and only error is you add the error of bill, having error in bill, or you have add the error of having at least one and only error from invoice, plus you add the error from having at least one and only error from the order. So if you add everything, you will get 0.056 plus 0.126 plus 0.216. What's the answer? 0.398. Okay. So when it comes to one and only error, it means you are referring to the O law. Remember that. But also the AND law. Both laws come into play. AND law and the O law when it comes to one and only rule. But when it comes to at least rule, we follow the complementary outcome formula, and the probability of not having an error, we multiplied everything because we are going to check this one. This is positioned horizontally. Not having an error and it is an order. Not having an error and it is an invoice. Not having an error and it is a bill. That is the reason we use multiplication in this point and the AND rule. Okay. So with that we finish contingency tables, and next let's look at probability distribution.
Thank you for watching the video. Stay tuned with castudies.lk for more lectures online.